Today, we're talking about black holes. What if I told you there's a black hole so massive our entire solar system would fit inside it? Or black holes so ancient they might have formed before the first stars even existed? In this video, I'm breaking down every major type of black hole, from the stellar corpses left behind by dying stars to the cosmic giants anchoring entire galaxies. Stellar mass black holes. When a massive star runs out of fuel, it doesn't fade quietly. The core collapses with such force it triggers a supernova, an explosion that briefly outshines entire galaxies. But if the star is heavy enough, usually at least 20 times the mass of our sun, the core keeps collapsing. Gravity overwhelms every other force, crushing matter down past the point where atoms can exist. What's left is a stellar mass black hole. These weigh between 3 and 100 times the mass of our sun, compressed into a region barely larger than a city. Imagine taking 20 suns and crushing them into a sphere the size of Manhattan. But here's the problem. Black holes don't emit light, so how do we find them? When a stellar black hole pairs with a normal star, it can steal gas from its companion. That gas spirals around first, forming an accretion disk that heats up to millions of degrees and glows in X-rays. By scanning the sky with X-ray telescopes, astronomers can detect these cosmic feeding frenzies. Cygnus X-1 is one of the most famous examples. Located 6,000 light-years away, it contains a black hole roughly 21 times the mass of the Sun. Stephen Hawking once bet that Cygnus X-1 wouldn't turn out to be a black hole. When the evidence became overwhelming, he conceded. We've also detected stellar black holes through gravitational waves. In 2015, LIGO made history by detecting ripples in spacetime created when two stellar black holes spiraled together and merged. For a fraction of a second, that collision released more energy than all the stars in the universe combined. Astronomers estimate millions of stellar black holes are scattered throughout the Milky Way. Most lie dormant, drifting silently through space like cosmic ghosts. But stellar black holes are just the beginning. Intermediate mass black holes. For decades, astronomers noticed a strange gap. We had stellar black holes weighing up to 100 suns, and supermassive black holes weighing millions of suns. But where were the middle weights? Intermediate mass black holes range from around 100 to 100,000 solar masses. They're rare, quiet, and almost impossible to detect because they don't often feed on nearby stars and don't sit in active galaxy centers. Most of the time, they're floating silently through space. But recently, we've caught glimpses. The globular cluster Omega Centauri revealed a black hole weighing roughly 8,200 solar masses by tracking how stars moved near the core. In 2009, astronomers detected HLX-1, an X-ray flash 290 million light-years away from a black hole ripping apart a star. The estimated mass, 20,000 suns. Here's why these matter. They might be the missing link explaining how stellar black holes grow into supermassive monsters. Imagine small black holes merging over billions of years, gradually stacking up mass until they become the giants anchoring galaxies. Or imagine one floating through deep space, rogue and hungry, drifting between galaxies with no light, no warning, and no escape once you're close enough. Supermassive black holes. At the center of almost every large galaxy sits a monster. Not orbiting, not wandering, but anchoring everything around it. Supermassive black holes weigh anywhere from 1 million to tens of billions of solar masses. Take Sagittarius A star, the black hole at the center of our Milky Way. It weighs about 4 million solar masses and sits 26,000 light-years from Earth. We can trace stars whipping around it at incredible speeds, some completing a full orbit in just a few years. In 2022, the Event Horizon Telescope gave us a direct image of Sagittarius A star, a glowing ring of light surrounding a dark shadow. That shadow is the event horizon, the boundary beyond which not even light can escape. It was the second black hole ever photographed, following M87 star in 2019. And M87 star makes Sagittarius A star look modest. This behemoth weighs over 6 billion solar masses, so large it would encompass all the planets in our solar system from Mercury to Neptune. But here's where things get strange. We're finding supermassive black holes just a few 100 million years after the Big Bang. That shouldn't be possible. Black holes should take billions of years to grow that large. Either something is wrong with how we think black holes grow, or the early universe was far more violent than we imagined. Many supermassive black holes aren't dormant. As gas spirals in, they heat up and release tremendous energy, creating what we call quasars. These aren't a separate type of black hole. They're supermassive black holes actively feeding. The accretion disk becomes so bright it can outshine all the stars in the host galaxy combined, with jets of material shooting out from the poles. Supermassive black holes don't just consume, they shape galaxies. Their energy can drive winds strong enough to blow gas out of galaxies, regulating star formation. Without them, galaxies as we know them might not exist. And when galaxies collide, their central black holes spiral toward each other and merge. Given enough time and enough mergers, a few black holes don't just grow large, they grow beyond supermassive entirely. Ultramassive black holes. At the upper end of the supermassive range sit the true cosmic leviathans, ultramassive black holes weighing more than 10 billion solar masses. The current record holder is TON 618, weighing an estimated 66 billion solar masses. If you replaced our Sun with TON 618, its event horizon would extend past the orbit of Pluto. The entire solar system would fit inside the region where escape becomes impossible. Phoenix A star is another candidate, estimated between 60 and 100 billion solar masses. These monsters are so extreme they push the boundaries of what black holes can theoretically become. There may be an upper limit to how large a black hole can grow before it disrupts its own feeding process. For now, ultramassive black holes represent the absolute peak of what gravity can create. Single objects with a mass of hundreds of billions of stars. Primordial black holes. Every black hole we've discussed formed from stars or grew within galaxies. But what if some black holes are older than stars themselves? Primordial black holes would have formed less than a second after the Big Bang. Tiny fluctuations in spacetime might have concentrated matter so tightly that gravity crushed it into black holes instantly, no stars required. If they exist, primordial black holes could come in a staggering range of sizes. Some might be smaller than an atom but weigh as much as a mountain. Others could be the size of a grain of sand but contain the mass of Earth. Here's why scientists care. Primordial black holes could explain dark matter. For decades, we've known galaxies contain far more mass than we can see. If countless tiny primordial black holes are drifting through space, they'd be the perfect dark matter candidates. Massive, invisible, nearly impossible to detect. But let's be clear. If a primordial black hole with significant mass passed through Earth, it wouldn't leave a subtle wake. It would be catastrophic, an extinction-level event that would tear through our planet. We'd definitely notice. Stephen Hawking theorized that the smallest primordial black holes might evaporate through Hawking radiation, though this remains theoretical. For any black hole larger than a certain threshold, evaporation would take longer than the current age of the universe. By the time the first stellar black hole evaporates, the universe will be cold, dark, and dead. Primordial black holes remain ghosts of theory. We haven't confirmed a single one, but if they exist, they'd be fossils from the very birth of the universe, carrying secrets from the first instant of creation. So, which type fascinates you most? Tell me in the comments, and if you want more deep dives into space, hit subscribe.